Hey everyone, it's Justin again. This video will go over problem number 1 from the section of your notes where you're converting from standard form to vertex form. Before using this video for support, make sure that you've worked through your PDF as directed and that you've given this problem your best shot. Our goal here is to convert this equation into vertex form. Since vertex form has the independent variable being squared, what solving strategy from earlier in the unit does this remind you of? This reminds me of the completing the square method of solving quadratics. And we actually will be completing a square here too, but the difference for this problem is that we're not solving for an unknown variable like we did earlier in the unit. Instead, we're making our function look like a different form. When you learned to complete the square, how did you get this constant term out of the way? Yeah, you moved it to the other side of the equation using an inverse operation. Here that means adding 3 to both sides of the equation. Now that we have the x squared and x terms isolated on one side, do you remember the next step to complete the square? We have to divide by the coefficient in front of x squared. Let's go ahead and divide everything by 2. Simplifying the division on the right gives us x squared minus 3x, which is exactly what we need to finish completing the square on this right side. Also, notice that I didn't spend time simplifying the left side of the equation by distributing that division. This is because later on we're going to be undoing these operations anyways in order to get y isolated again. Now that we have x squared plus an x term, go ahead and try completing this square. We can split up the negative 3x evenly to become negative 1.5x 2 times. Then we need to fill in that final box. Negative 1.5 times negative 1.5 gives us 2.25. Okay, so we know 2.25 needs to go here to complete the square, but we can't just add an additional number into one side of our equation because then our equation wouldn't be balanced. What do we normally do to keep an equation balanced? We can add 2.25 on the left side of the equation, like this. But knowing that our end goal involves getting the y by itself again, I actually have an approach I think might be helpful here. We can subtract 2.25 on the right side to balance it back out, since adding and subtracting the same number is equivalent to adding nothing at all. Then our equation will still be balanced. It'll just have some extra numbers in it. Yeah, let's go with this second option and keep this extra operation away from the side containing y. Now that we have the square completed, our function is starting to resemble this form quite a bit more. But what do you notice is different about what we have so far and our goal? Yeah, we don't have y by itself. So how can we get y by itself? Let's get rid of the 2 and the 3 using inverse operations. Multiplying by 2 will cancel the division by 2 on the left side. On the right side, we multiply the square by 2 and the constant by 2. Now we can subtract 3. And just like that, we've reached our goal. We have vertex form with an a value of 2, an h value of positive 1.5, and a k value of negative 7.5. This is great. Now that we've gone through this problem, how confident are you in your understanding of this method? If you're thinking it's a little challenging and some additional practice time would really help you, go ahead and stop this video here so you can focus your attention back to the practice in the PDF. If you're feeling confident and ready to challenge your thinking a bit more, then continue this video and come with me. Let's explore the efficiency of this method by looking back through the steps we took. Did you notice that our first step of adding 3 was later undone by subtracting the 3 back out? And early on, we divided by 2, but then later we multiplied by 2. Using these inverse operations just canceled back out the steps that we initially took. And that may seem a little inefficient, but the reason for those initial steps was to get those operations out of our way. Then we could focus on completing the square in the same way we're used to. For some of us, like Mia here, having these operations out of our way helps us avoid making mistakes. But there is an alternative approach that we can explore without these steps in it. For this alternative approach, we can move the -3 out to the side a bit so we have some workspace for completing our square. And we'll factor the 2 out of the x terms. Then we're ready to complete this square, just like we did earlier on, giving us 2.25 to include in these parentheses. Now, do you remember what we need to do when adding a new number into our equation? We need to balance it back out. But there's something happening here that we're not used to. When we put this 2.25 into the parentheses, we didn't actually add 2.25 into the right side of the equation. What did we really add to the right side of the equation? We added 2 times 2.25, which is 4.5. So how can we balance this back out while still keeping y isolated on the left? To balance this back out, we can subtract 4.5 on this same side that we added it to. Now, our square is complete. Remember our goal. Can you make this look like vertex form now? We need to write our completed square as a square and combine the constants like this. And there we go. This is the same vertex form we got when using the other strategy we talked about earlier. Using this approach, we're able to keep y isolated through the entire process. It's completely up to you whether you prefer this method or the previous method. Now that we've explored these options and worked through this problem together, try out problem number 2 in the PDF on your own. Good luck, and I'll see you next time.